All right, so let's just do a few examples, and these will go pretty quick, so I've got quite a few up here. Again, my suggestion is when we get a new batch in, just stop the video to try them, and then go ahead and play the video again so you can see how you did and any process that you might have missed or need to be reminded of. So let's go ahead and do our first one. All right, so let's go ahead and look at this first one. We've got p squared minus 100. So the first thing we do, of course, is to make sure that they're both perfect squares, and then we decide they are because p squared, obviously, and 100 is 10 times 10, so we write our double parentheses. We take the square root of p squared, put it in the first position, square root of 100, put it in the second position, put in our plus and our minus, and we're done. So once you get used to doing these can be one of the easiest factoring projects that you do. So the next one, we've got a little bit more going on. And what we have here is we have a coefficient and a constant. And we see that that coefficient is not a perfect square. But what we also need to remember is whenever we look at any factoring problem, the first job is to look for a greatest common factor. And this is a greatest common factor. So 2 is a greatest common factor. When we divide 2 out, we get y squared minus 49. And now we see that what's left in the parentheses is a perfect square. So y squared and 49. So we bring our 2 with me. We never get rid of the greatest common factor. We just drag it with. And we put our new 2 parentheses in there. Simplify, square root of the first term is y. Square root of the second term is 7. And then we just do a nice little plus and minus. Now the next one that we've got going on here, this is just because there's no constants, it's 2 variables, but it works exactly the same way. We see x squared and y squared are both perfect squares. So that tells us we've got the difference of perfect squares, of course, because there's a subtraction there. And the square root of x squared, easy enough, x. Square root of y squared, again, just y. And then we toss in the plus and the minus, and we're done. And of course, remember that for a while you may want to do some multiplication just to check and make sure that you are getting what you're supposed to be doing. Now we look at this bottom one here. We've got 64 and 81. We want to see if there are any common factors. Now, when we analyze this, if you need to go and do this and do a factor tree to see, 64 just has factors of 2, and 81 just has factors of 3. So that tells us that there is no GCF. However, they are both perfect squares, as is x squared. So the square root of 64 is 8. And the square root of x squared is x. And the square root of 81 is 9. And then we just put in our plus and our minus. Okay, let's do a couple more. So we look at this one and we see, again, we're always looking for, are they perfect squares? 25 is a perfect square, p squared is a perfect square, 64, q squared, all perfect squares. We look for a greatest common factor. We don't have the same variable in either term. And 25 only has factors of 5, and 5 doesn't go into 64, so there's no GCF. So we get done all of our prep work, and we put down our double paren. Square root of, and again, we're just going to look at each thing step by step. The square root of 25, first position. Square root of p squared, still in the first. Square root of 64. And the square root of q squared. So do you see how we just literally go through and pull the square root of everything, making sure we put it in proper place, and then we just put in our plus and our minus, and we're done. Now, sometimes they can get a little bit longer, and this one gives us an example, is a nice example of that. So again, we look to see if they're perfect square. Now, remember, 1 is a perfect everything. It's a perfect square, it's a perfect cube, it's, just a nice little number that works for everything. P to the 8th is a perfect square because that idea of P to the 4th times P to the 4th, and 4 plus 4 is our 8. So perfect squares. So now we're going to put our parentheses, and we know that it's P to the 4th times P to the 4th, and we know 1 is of course 1 times 1, and then we do the plus and the minus. Now this is really the reason why I like to put the plus first, because we know the sum of perfect squares is not factorable. We already talked about that in the last video. The ones that are factorable are the ones with the negative. And then we look at this one and we see that this is still a perfect square, and this is of course still a perfect square. So we bring this down, and now we're going to refactor this one. So the square root of P to the 4th, of course, is P squared, and 1 and 1, and again we put in our plus and our minus. Again, the repeat. I put the plus first because I know I can't factor it. I always want the negative to be on the ends because it brings my eye to that, and I know that I can keep checking it and just bring the stuff down if I need to. And as I look at this, I can see that again, this is a perfect square and this is a perfect square. So I can factor that again. And the idea when we are doing factoring is we want it to be in its most factored form, which means if you can factor something, you must. So the square root of P squared is P, and then we've got the 1, and again the plus and the minus. And now we look at this and we can see that we're done. Now, one of the ways that you can see that you're done is when we look at the one that's got the minus, we see that this doesn't have an exponent. The variable doesn't have an exponent. So that's one way, at least at this point in your math life, that's one way to know that you're pretty much good to go now. Now let's go ahead and take a look at the next one. And the next one has a coefficient, and it also has a constant here. We can see that 5 goes into 405. So that is our greatest common factor. And then we just divide it out of each term. So we're dividing, this term by 5 and dividing this term by 5. And now we divide that out and we get 81. So now again, we see what's inside the parentheses, and we see that this is again the difference of perfect squares. X squared is a perfect square, 81 is a perfect square, and of course there's a minus in there. So we bring our greatest common factor down, do our double parentheses, square root of x squared, the square root of 81, and a plus and a minus. And again, we can see that there's nothing else we can factor. And we look at the exponent on this, we see that it's 1, so we're pretty much good to go. So again, my suggestion is go ahead and pause and try these. These are a little bit more complex just because, at least this one is just a little bit more complex just because it's got a bigger exponent here, but it doesn't change anything. We know that any exponent that is even is a perfect square, so we're okay with that. And of course 16 is a perfect square. So again, we just put our double paren down. And the square root of x to the 12th, we just divide that in 2. So x to the 12th is x to the 6th. Because remember, 6 plus 6 is our 12. The square root of 16, of course, we remember that is 4. And then we put our little plus and minus. And then we look to see if there's anything else we can do to factor that. This is the sum, so there's nothing I can do. But here, again, that is a perfect square because it's even. So we're going to do our double parentheses again. So we'll have x to the 3rd this time. And the square root of 4, 2 times 2. And then again, a plus and a minus. Now we see that this is odd, so we know that that's not a perfect square anymore. So again, that's one of the things that we can look at to see that we're done. The next one here, we see that we're always looking for greatest common factor. We see that there is an x in both. So we're going to pull that greatest common factor out. And when we divide the greatest common factor out, that's what we're left with. And we can see perfect square, perfect square, perfect square. So now we do the double paren. Square root of 36, square root of x squared, square root of 49, plus, minus, and again we see the exponent on that 6x is 1, so we know that we're pretty much good to go on that, and we are ready to move on to our next problem. Let's do one more just because I want you to see what happens when it's all variables. The difference is, from my perspective anyway, it's actually kind of easier. So you just have to think about it from the right perspective, and that is, we're just looking for perfect squares. So do I have perfect squares? So remember, when we're doing variables, all we're looking for is, are the exponents even? And when they are, we know they're perfect squares. So all of those have even exponents. I'm going to give myself a little bit more room because all those variables are going to take up some space. And I'm just, again, going to go one by one. X to the fourth square root is x squared. Y squared, square root is y. Got my 2 there, sorry. P to the fourth is p squared. And q squared, square root is q. And then we just do a plus and a minus. Now, how do we know if we're done? We can tell that we're done because we have several variables that don't have an exponent, which means they have an exponent of 1, which isn't even, so they're not perfect squares.